trust their teachers. I suspect it is less. I don't really suspect that, but just as an example. SRS of 40 students. 30 say they trust their teachers. So if the school is claiming 80%, like I don't know if it's really that high. So I take an SRS and I come out 30 out of 40, which is 75%. So if they claimed 80% and my little sample says 75, is that far enough away for you to be like, hold up, something's wrong? Like, I think that's probably fine. I'm not gonna be able to prove that they're right, but I don't think that's enough for me to call them a lie. But let's go through the math and see what the math says. So again, we are doing a one proportion Z test. And I want to start by defining what P is. P is the true population proportion of students that trust. And I don't want to write the teachers, because I'll have to go to the next line. Oh, that's all right. Can't be wasting space on paper like that. All right, so I'm going to make my HO is the null hypothesis. This is always going to be something equals something, and it's always like the initial claim. So in this case, they're claiming that P equals 0.8. But the true population proportion of students that trust their teachers is 0.8. That's their claim. I'm going to try to show that it's not that high. So I'm going to do P is less than 0.8. We will do greater than not equals, because also I'm just sticking with the less than, because that's what we just did. I'm going to write down P hat. P hat is 30 out of 40. So 0.75. And alpha was not given to you. And if it's not given to you, you assume it's 0.05. Let's say usually, but not close to always. Maybe 75% of the time. All right, conditions. So SRS is stated. Independence is the 10% thing, so 40 is less than or equal to 10% of MHS students. And the normality, like we barely qualify for that. We need at least 10 successes and failures, right? How many successes do we have? It's 30. So how many failures do we have? It's 10, because it's just like the other 10. So we do have it, but barely. So 30 successes. And failures are both greater than or equal to 10. These are kind of, you don't have to separate them, but those are kind of different sections. It's like your intro. Conditions. You don't need to write these words. You don't need to separate it. It can just be one giant information sheet. But this just helps some people like separate it in their brains. All right, math time. So Z is always equal to the statistic minus the parameter divided by the standard deviation. So that's writing the formula in words. Realize that I've already like reduced this down as much as you can. If you start trying to like reduce down what I'm writing, you're missing important things. So don't, like, I've already shortcutted it. You can't shortcut anything I'm doing. You have to show all these steps, or you're going to lose points. So like showing it in words, showing it in symbols, showing it in numbers. You might be like, I don't have to do that. I agree with you. You don't have to do that to the problem. On a multiple choice, I wouldn't do it. But on a free response, that's part of earning your points. Okay, Okay, so statistic is P hat, parameter is P, standard deviation is the square root of PQ over F. Alright, what's P hat? 0.75. What's P? 0.8. What do I put in for this P? 0.75 or 0.8? 0.8. That's P. You use P. So go ahead and calculate what that is. I get negative 0.79. Agree? What next? I remember, look at your sheet. Sketchy. So negative 0.79 is less than 1 standard deviation away. So like 3 standard deviations all the way at the tail, 2's probably here, 1's probably here. So we're like pretty close to the middle. So that's your z equals negative 0.79 is this line. And why did I shade to the left instead of the right? It's because there's a less than sign up here. You're basically, I've learned that there's like a lot of kids in like AP Stats and AP Calc, like obviously really strong math students, they like mess up less than an equal to. They're like, it trips you up. That happened to you in Calc. Yeah. I wasn't trying to call you out, but you were one of the ones I was thinking of. So like it might help you just to like use shade, like that's an arrow, right? It's pointing to the left. Shade the way the arrow's pointing. I know that sounds like alligator like cheating, but I don't know.
That's how we can write pointing is
It's greater than P.
yeah, so then your arrow.
So don't write it that way. I don't know what to say about
Yeah,
it.
the alligator needs to be that's how I do it.
Yeah. I'm just trying to explain the shading. Yeah, no, I know. Okay. I want to find the p-value now. To find the p-value, I'm going to use normal CDF. And I've got like a lower bound and an upper bound. So my lower bound, because it's shading all the way over to the left, is negative 99999. And my upper bound is this z-square. Negative 0.79. So type that in and let's see what we get. So I get 0.215. Remember, smaller p-values means a smaller chance that they're correct. So that is not that small. And more importantly, it's not small. It doesn't matter like what I think is not that small. It's not smaller than that. So this is your cutoff point. If we think the probability they're lying, they're telling the truth, is less than this, we're gonna call them liars. In this case, the probability they're lying is actually greater than the probability they're truthing is actually greater than this. So this is higher than 0.05, which means we cannot call them liars. So we cannot reject their claim. So we're gonna like be like, yeah, we think you might be right. So since the p-value is greater than alpha, it's the opposite of the last one we did, right? When the p-value is greater, then we cannot call them a liar. So we're going to say we fail to reject H of. So that's like you filed a lawsuit and lost. Like, yeah, I tried to sue you, but I failed to win. And we're failing to win because, so the last time I said there is enough evidence to support this alternative idea. So now there is not enough evidence to support that idea, or convincing, or whatever. So there's not sufficient evidence, or there's not enough evidence, or there's not convincing evidence to conclude P is less than 0.9. So if I were to rephrase that in like non-statistical language, since the probability you're telling the truth is greater than my cutoff point, I can't call you a liar. There's not enough math evidence for me to call you a liar. That's kind of what we're saying. So tomorrow I'll give you like a template where I just kind of guide you through, like without a problem, but like here's what you put here, here's what you put here, here's what you put here, and that's what you might want to put in your packet. But that's up to you. Are there any questions I can answer on this? Again, I know it's like a lot and overwhelming, but anything you can point out, like explain this again. I don't get this. Okay. We got it, man. I might like right to the almost last hour, but we're good. Did I sign the con on this yet? I did. Only two. Okay. So you can start on that if you want. You can sit here if you want. Okay.